Okay, welcome. Sorry for the inconvenience, technical difficulties for some reason. Anyway, my name is Jiří. I work for SUSE OpenStack Cloud team, and I want to talk about the upgrade of our OpenStack product. So, just for the beginning, who of you guys are actually using OpenStack somewhere? You do not count. And SUSE OpenStack Cloud, yeah. And do you have anyone experience with upgrading it? Okay. Yeah. Okay. Thanks. So, just want to say, well, I was involved in developing the upgrade solution for two of our releases, and I want to basically focus mostly on some technical difficulties we've met. If you think you want to ask right away, try to ask right away, and there might be, or maybe save your question to the end. But yeah, we'll see. So, what do we want to talk about? Basically, about upgrade in general, and I want to introduce something we call non-disruptive upgrade, and I would like to talk about specific technical difficulties we've met while developing this. So, why do we want to upgrade, or why do you, as a users, want to upgrade? Unless your software is a feature complete and bug free, you basically want new features and bug fixes. But the problem is that OpenStack release cycle is that there is a new upstream release every half a year, which is not what every cloud distribution follows. For example, SUSE does usually release of their product every once a year. That means we are not releasing every upstream OpenStack version. That means we need to skip release somehow, which is not, or at least was not at the time of development of this, wasn't officially supported upstream. So we have to find some solution how to overcome some difficulties. Now the next question is, how would you like to, how to do the upgrade and not to affect the users that are using your cloud? To be honest, we cannot really say we cannot affect them at all. So let's just say we don't want to limit the users that much. And that's where the buzzword called buzzword non-disruptive comes in. Well, this is something when we originally got the assignment of working on upgrade, had to figure out actually what does the non-disruptive upgrade mean, or what should it mean? So there might be different kind of meaning. We basically decided, and that's the way we promote it, that non-disruptive upgrade in our terms mean that existing workloads are functional during the whole upgrade. That means you have instances running on your cloud, and although the upgrade could take hours or days, I don't know, they should stay running, they should stay functional, they should be reachable from the network. Obviously, there are some limits. You cannot create new instances, you cannot close existing ones, you cannot use most of the OpenStack services. That's what we actually found out in our solution, that we are not able to provide API availability during the whole time of the upgrade, but we try to minimize it. Right. Also, the last point is actually might be actually interesting. So when we were developing this non-disruptive upgrade, we found out that maybe not every user actually needs that. Maybe someone just wants to upgrade as fast as possible, and they are fine when they shut down all the instances, or they suspend them, do the upgrade, and then just bring them back. So that should be also possible of the upgrade solution, also possibility. It's actually faster. I will go into details later.
Is it a fair summary to say you keep the data plane running, you are
Sorry, once again.
You keep the data plane running?
Yes, yes, but and yes,
control plane has downtime.
yes, control plane. Like that's what we mean when I saying OpenStack services are down. Yeah. Okay, so what clouds are we talking about? Basically, our experiences with SUSE OpenStack Cloud 6, 7, and 8 versions. They are deployed on regular or virtual hardware, so there are no containers. That the containers will be coming with Cloud 10. So we cannot benefit from any fancy container solution that basically does the upgrade for you. Our cloud distribution is using Crowbar as the deployment and configuration tool. That is basically a Ruby on Rails application that runs on a dedicated server and uses Chef to distribute the configuration to your cloud nodes. Yeah, so there is this admin server. Oh, yeah, admin server that is actually running the Crowbar application and contains the Chef cookbooks that all the nodes are reading, are using. And obviously everything runs on SUSE Linux Enterprise server, every node including the admin server. Now, every cloud version has a different version of SLE, right? Specifically a different version of service pack. So we do not need to upgrade just the OpenStack packages. We need to upgrade all the packages. We need to upgrade the whole system. That also means new kernel. Reboot is required after upgrading every node, that is admin node and every cloud node. So just a summary, what we are talking about. In Cloud 6, we had OpenStack Liberty release, and it was running on SLE 12 SP1. Cloud 7 is delivering Newton, and it's running on SP2. Cloud 8 is using Pike, is delivering Pike, and it's running on SP3 version of SLE 12. And yeah, I am talking only about the Crowbar version of SUSE OpenStack Cloud 8, because Cloud 8 was also delivered with alternative management system that is using Ansible. So I'm not talking about it in this session. So what would be the basic idea behind the upgrade, how to do the upgrade? We require the setup to be highly available. That means we have pacemaker clusters on control plane. Every service is running basically active on each node of the cluster. So the idea is take one node of the cluster, shut down services that are running on that node, upgrade the node, and while the node is being upgraded, the rest, the other nodes in the cluster could still provide the services, right? There is definitely there will be some downtime, because at the point when we will be shutting down the services on the old node, and when we would be switching to the new versions, everything needs to be down for a while. So that's very basic idea how to upgrade the control plane. Basically go one node by node in the HA pacemaker cluster, and yeah, after the whole control plane is upgraded, we proceed with compute nodes. And the basic idea here really is to use Nova Live Migration. That is, we take one compute node, we find out, we use the live migration or live evacuation. We basically move every instance that is running on that node to all the other compute nodes or to everywhere else. Then we disable the service on the node, so it is so Nova Scheduler doesn't use it for the time of the upgrade. We could upgrade the packages on the node, reboot it, run the Chef client that is basically reconfiguring to new version of OpenStack, and start the new services. And we can continue with next compute node. All right, that sounds simple indeed. but it isn't.
Live-migrate features in most of the providers from the storage standpoint. What do you do for the persistent volumes attached?
So what do we do with?
For the persistent volumes attached to the Nova instance, they don't migrate when you do a live migration. For a single volume that is attached to the instance.
If you have local storage on a local disk.
Local storage is not supported in this scenario. Well, I will come to the slide where we basically talk about there is specific set of prerequisites that have to be met so that this non-disruptive option is possible. So basically, you use Ceph as a storage backend or something like that. Yeah. But as I said, it doesn't mean that the system cannot be upgraded. But it just won't be upgraded this non-disruptive way. It won't be using live migration. It will tell you you have to stop all your instances, then we do the upgrade. And as I just said, with this, basically, when we are going node by node, it takes quite some time, right? So if we would not care about this non-disruptive version, we could just upgrade all the compute nodes in parallel. So yeah, there's a disruption. All the workloads are down, but the whole time for the upgrade is shorter. Okay, so the same, but in picture. Basically, imagine you have control plane in pacemaker cluster. There is some HTTP proxy that usually provides some unique point to the API. You are using API from command line or from web UI, and you have some compute nodes, some VMs running on the compute nodes, right? While we are upgrading the first controller node, we can still basically provide the API. I call it version N, basically the old version, and that could be provided by the nodes of the cluster that are not yet upgraded, right? This is basically old nodes. Once the first controller node is fully upgraded, we should be able to switch the services to the N+2 version and stop everything on the other nodes in the cluster, and only the upgraded node would be the one providing the API.
And that's also the point in time where you do the database schema upgrades.
We come to that.
Okay.
Yes, but yes, yeah. So it is not as simple. You know, we do not really switch in a matter of seconds. There's actually some time that when we are reconfiguring this first node, that means that the chef client is running on the node, and that could take like 20 minutes or so, depending on your hardware and setup. So, and for the whole time, all the services are down. And yeah, the schema upgrades are part of that. Yes, we will come to that. So another picture, basically, to show you how we access, how we do the configuration. As I said before, we have this admin server where the Crowbar application is running, and the chef server and the chef cookbooks are located, and chef clients from all the cloud nodes are using these. So the configuration in the usual way, when Crowbar is operating, where Crowbar is basically operating for deploying your cloud and for reconfiguring whatever you need to configure, like specific option in Nova setup, or I don't know if you've ever seen Crowbar. It's not really my idea to show it, but yeah, you get the point. Basically, configuration tool. For the upgrade, we found out that we cannot really use Chef for everything, because we need to orchestrate the set of steps in a more precise way, and Chef doesn't really allow that, or at least the Chef version we are using. So we had to add another layer we use the chef for distributing of specific bash scripts to all the cloud nodes, and then we are using this Ruby on Rails application to orchestrate the order in which those scripts are executed. And just as an example, those scripts are doing things like setting up repositories for a node, upgrading the packages, or migrating network routers, and stopping the services, and so on. So now I would like to talk about specific problems we've met. So yeah, let's talk about Nova for a short time. So let's assume we have this control plane fully upgraded, the way I've briefly said before. We took one node, upgraded it, another node, and so on. We have control plane running, and it is using new version of OpenStack release. Now, compute nodes are still using the old version. So the question is, does it work? The answer is, it depends. What does it mean for instances? They should be still running, right? We did not touch did not touch compute nodes yet. They still should be reachable by network. I will talk about it later. But let's assume they are still reachable. But now we want to do those migrations, so we need to Nova API to execute Nova live migration actions. So Nova on the control plane needs to communicate with Nova service with Nova compute service that is running on the compute nodes. Now, this seems to be working fine mostly when we are doing this switch, this upgrade from Newton to Pike, that is from Cloud 7 to Cloud 8. When we were doing upgrade from Liberty to Newton, this basically stopped working. So at that time we solved it by a dirty trick that right after we upgraded all the whole control plane, we did only small action on compute nodes. We just upgraded the packages that were related to Nova compute service. So basically only some Python packages were upgraded to new version, but the compute nodes were still running on the old service pack, and most of the packages were still from Liberty. Fortunately, it did work, but the system was kind of mixed, and we were lucky that we were glad that we did not have to do it in next release. Now, does it really work? When I said it does work fine when going from Newton to Pike. Well, it does, but we have to make sure we pin the RPC API version correctly. So there is a specific option in Nova configuration called upgrade levels, and if we set the compute value to auto, that means that the RPC versions that are used for communication are set to the lowest version that is available for existing Nova services that are written in the database. So with this option, basically the Nova is still using the version that is from Newton, although some of the services are already running Pike. Yeah, at some point we actually want to tell it to switch to the latest version. So there is a manual step required. Well, not manual. I mean explicit set required at the very end of an upgrade when we know that everything is already running new version. We just have to go to each node and just send the SIG-hub signal to all Nova services. So they basically reload the configuration, find out that indeed all the Nova services are already using the latest version, so they could start using latest version of RPC. Yeah, just yeah, that's it. Basically, this was not really necessary for everything. I mean, it was only some operations were affected. If for example, if you wouldn't try attaching volumes, you would not even need to use it. But yeah, that would be obviously wrong. Simple live migration would work even if the RPC would not be pinned correctly. That's what I'm trying to say. Sorry for. Okay. Yeah, another Nova detail, Nova placement. That is a new service. Well, new service, that's not new service now, but at some point, Nova placement was introduced as a new service that was managing the resources, as far as I know, used only by Nova for managing compute resources. It was introduced in Newton version, but it was made mandatory since Okata. And as we are upgrading from Newton to Pike, we are basically skipping Okata. So that is a problem, because if we would just simply upgrade the packages and restart the new services, they would just refuse to start, telling us something like placement is not configured or something like that. That is required. So, as I said, it was already included in Newton, but it was not really nicely working. There were several bugs in Newton release regarding placement. So what we did, we had to patch, backport some patches from Okata, or maybe even from Pike, back to Newton. And then we released maintenance update for SUSE Cloud 7 that basically reconfigures your services to use placement already in Newton. So that Nova is using it already before the upgrade if we make the hard requirement that all the maintenance updates are installed, right? So before the upgrade, as I mentioned before, we have list of checks. One of them is basically that all the updates are required, and one of the update brought the placement configuration into your OpenStack Cloud 7. Okay, so that's mostly about Nova. Well, not really. As I said before, that instances were running, but what about the network connectivity? The problem is if we would just shut down all the nodes in control plane, we would lose the network connectivity. So what we need to do not shut the specific control node that is actually providing the network. We need to shut down all of them at some point. But what we have to do is basically before, when we pick a node to be upgraded, we need to evacuate all the routers and load balancers from that node so that the network is handled by some other node in the cluster. That node could be actually not upgraded one, right? There was no version specific problem. Yeah, that was a necessary step basically to do this evacuation. Then we could finish upgrade of the control node, and once this is finished, we need to bring those routers back, right? Because next time we will be upgrading another node. So that's it basically. Yeah, this is not really relevant. I may have said that we are stopping all the API services, but this is basically when we found out that we need to let some services running for a little bit longer, but like Neutron and basically dependent services. Neutron HA tool is actually the Python script that we are using for this action. It is using basically the API of Neutron. Originally, we started using it for the HA for some HA control in our pacemaker clusters, but we extended it for this usage as well. So that's publicly available in GitHub. And could you, yep. So, and now the database schema, obviously. So that's another interesting problem, because of course every service has its own database, and when you upgrade to new version, the database schema could be different. So every service actually contains this dbsync command, which does the migration of database schema and adapts existing database entries if necessary. Usually it is in our workflow, it's basically executed directly after the packages are upgraded. Now we see actually the main reason why we have to shut, at some point we have to shut all the services down, because once we upgrade the schemas to the new version, we cannot let the old version of services run. They would not be able to use the updated database schemas. In general, like, it might be possible for some specific service, but usually there are some changes. Now, this mostly seems to work, but there are some exceptions. We found out with Cinder, there was this online data migration that was introduced in Okata release that is doing the data migration in the database. And what is the problem is that by default it is actually required to be run from Okata source, right? But we do not have Okata. There is actually some migration in the dbsync. In the dbsync that is run in the next version, in Pike version, there is specific check that the online migration was already executed before. So we just could not simply skip it and ignore it. So we just briefly considered the official OpenStack position, which would be maybe installing Okata packages temporarily, doing this database operation, and then again upgrading, then finally upgrading to Pike. But fortunately, it wasn't necessary. What we did, we actually moved that online migration code. Oh, not the code, not the framework, but the specific migrations that were part of Okata's online migration call. We move it to our Pike version of the packages, and we call it only from Pike. We do it this way. Basically, do first the dbsync only to certain revision. That was the revision was probably right before that online migration should be run on Okata. Right? Then we would do this online migration, and then we could safely do this dbsync from Pike, because what is different that this online data migration call is actually executed from Pike and not from Okata, and it is possible because we just moved some part of the code from one version to another. Fortunately, it was not such a big part of it. Was basically two functions, I believe. So we met something similar when we were doing this Cloud 6 to Cloud 7 upgrade, but at that time the problem was with Nova. But again, we solved it the same way. Like, we moved one piece of code that was responsible for a specific database migration from one release to another, and it worked well enough. Now, Nova has also online migrations. What is different that unlike with Cinder, where we basically need to run it before dbsync, Nova online migration has to be run at the end of all migration. Basically, once all the Nova services are upgraded, right? So in Nova case, we upgrade only after we upgrade all those compute nodes to Pike, and after we restart all the services so they are using correct RPC version, like I mentioned before. That's the time. Basically, that's the last action during the upgrade when we run Nova online migration. So yeah, so that was interesting. Like it's done quite differently. This is not really a problem itself. This is actually a feature that we've introduced in this 7 to 8 upgrade and call it postponed upgrade. So as I mentioned, we upgrade the control plane and it is running new version of OpenStack and yeah, we have the versions to, we have the ways to say that Nova is able to communicate across the versions. So in this case, it seems that we have basically usable cloud, right? Compute nodes are not upgraded, but Nova doesn't seem to care that much. So we can say, okay, you've upgraded your control plane, and now you could take a break, right? You could maybe upgrade your compute nodes like in a week or after another month, because now your cloud is basically functioning. So we introduced this postponed call. I want to mention it at the end. We basically have this upgrade UI or upgrade command line tool, and user is supposed to use it to start several upgrade steps in specific order. So now there is an option that the user can say, I'm postponing the upgrade of compute nodes, and it basically tells Crowbar, the management application, that it could be used, and it could be used to modify the configuration of that is related to control plane services. Because normally during the upgrade you cannot really use Crowbar to reconfigure anything. It's forbidden. There's basically a check in the Rails application that when the upgrade is running, users should not use Crowbar to any kind of reconfiguration. But if you say I'm done with control plane and compute nodes could be postponed for later, that's the time when actually Crowbar allows it. And yeah, then when user decides it's time to upgrade the rest, it just issues another command that means that tells resume the upgrade, and it could be and the rest could be upgraded. Now, as I mentioned before, there's obviously we need a list of supported scenarios. Not every was mentioned before that, for example, Cinder cannot use local disk as a stub, and yeah, this is not a complete list of checks, but this is just a list of some examples. So we basically, before the upgrade starts, we do a list of pre-checks that are necessary, and one of them is basically checking the pacemaker cluster health or Ceph cluster health. So it tells you your pacemaker is behaving weirdly, you have to fix it before you start with the upgrade. Or all the latest updates must be installed. If they are not, upgrade cannot be started, and so on. Service collocation, okay, I should have mentioned it before, right. So I was, when I was mentioning that, that you have basically functioning cloud, although compute nodes are still not upgraded, that applies when only Nova compute services are on compute nodes. If you have, for example, Cinder volume services there, that would not work because Cinder requires all services to use the same version. So, so we basically do a specific check for this collocation, and we say users, okay, there is a Cinder volume running on compute node. Non-disruptive upgrade won't be possible, something like that. And we check for database backend. I actually haven't mentioned that yet, but as part of the upgrade, we have to switch from Postgres to MariaDB. So before the upgrade, I wanted to go I will get to that. Okay. These are some notes that some funny stories we hit actually in development lab when we used admin server for the stuff that admin server is not supposed to be. So I said before, admin server is supposed to be kind of independent node that is just running the crowbar, and should not affect your OpenStack services that are running on the cloud nodes. But in test lab, you sometimes use things not the way you are supposed to do. So for example, we put the Cinder storage on the admin node, and when we were then upgrading admin nodes, obviously Cinder was affected by that. Or we even used the Stoneit setup wrongly, and we did not use independent and safe node for that. And again, we used admin node for, I think it was SBD or something. And then when admin node is upgraded, which is actually before all the cloud nodes are upgraded, Pacemaker realized, oh, the device is down. We should shut down a whole cluster. Well, yeah. Okay, and that's another big point is database upgrade and migration. So SUSE OpenStack Cloud 7 is using Postgres as a default database engine, or at least it was. And we decided that with Cloud 8 we want to switch to MariaDB as a default. Because, well, we've seen that the community is going that way, so that was the decision. We have to find a technical way how to upgrade, how to find an upgrade path that doesn't hurt users, right? Because when you switching the database engine doesn't seem as an easy operation. So we had to ask several questions. Yeah, we know that we need to change the database engine. One of the questions was, it's not just switching the engine that OpenStack services are using. We need to migrate all the data from the old database to new database. So the question is, when should we do it? Before the upgrade, or as the part of the upgrade, or maybe we should do the upgrade using the Postgres, and once we are in Cloud 8, then we do the database switch. Another question was, where should we deploy this new MariaDB instance? We should allow users to deploy MariaDB at some point, but it has to run somewhere, right? So we considered an options that we tell users, oh, you need to bring some new hardware to your setup, and that would be running MariaDB. But ultimately, we found a ways where it is possible actually to deploy MariaDB on the same nodes that are running Postgres. With one exception. In HA setup, it's actually possible that Postgres was using only a cluster of 2 nodes and using DRPD as a synchronization mechanism. But MariaDB's HA setup, which is called Galera, that needs at least 3 nodes. So this is not technically true if you know how Galera works. It actually could be configured for a 2-node cluster, but that's somewhat non-standard setup, and we basically decided to support only 3-node cluster Galera clusters. So we are in the situation where we still might need to ask users that there is 1 extra node needed, but it's still better than telling them 3 nodes are needed, right? So that was basically our logic. So you can reuse your original 2 nodes that are running Postgres as 2 new nodes for MariaDB, and then you have to add extra 1 node to form a 3-node cluster. And yeah, and basically also we had to figure out how to actually first just deploy this MariaDB, just set up Galera cluster, let it configure correctly and let it run, but first just run it empty, right? Not being used by OpenStack. And this is mostly questions. This is something with the, this slide kind of covers the answers. So we decided, yeah, that was the answer for the first question. So when we do the migration and when we do the switch, so ultimately we actually decided that we tell users to do the whole database switch still on Cloud 7 side. So we backported this MariaDB support into Cloud 7, and we expect that users will be able to switch database in Cloud 7. And then before the actual upgrade starts, we only check that MariaDB is already the default database engine. So basically we made it a different non-upgrade problem, right? So upgrade is not dealing with database change anymore. Upgrade just assumes there is MariaDB already running and configured. We only had to figure out how to do the migration. So I'm not really going into details. I mean, if you would be interested here, there was a whole session about this in the last OpenStack Summit. But so just very shortly, we, as I said, we let user to deploy, to set up empty MariaDB, MariaDB setup, MariaDB database in his database cluster. We use existing tools to create schemas and databases in this new MariaDB database. As I said before, those DB sync calls that are used to upgrade database schema to the latest version, they are actually able to create database if it doesn't exist. So we make sure that the freshly deployed MariaDB database actually has the correct database structure, correct schema, and we create all the database users. Then we have to stop all the OpenStack services, so they are not producing any more data. Then there is a step where the data should be migrated, and finally we can reconfigure all the services that they point to the new database. So again, this might look simple, but the problem was that the migration of SQL data, again, is not as simple as it might look like. I mean, you might think that two database engines both using SQL should be easy, and you have two engines, it should be easy to just migrate, but it's not that case. There are some issues specific to databases themselves. There are some of them specific to OpenStack. For example, for some components, OpenStack is using different schema based on the different backend. Right now, I don't really know which of them are. I think it might be Ceilometer. I'm not sure. I took it from the slide of the guys who did this part of the presentation before. Another issue is that MariaDB or MySQL actually doesn't support full character set for UTF, right? So, but you can have it. You can have it in Postgres. So you can have some of those special characters, like some special Chinese characters, I believe, or Japanese. I'm not sure. On those that could not really exist in MariaDB database. And yeah, one of the other issues is that the text type in MySQL has the size limit, while it has not in Postgres. So we thought someone had to do it, right? I mean, we were looking for existing tools. We found some of them. None of them was really good enough. Well, I think they maybe they were doing migration correctly, but they were not specific to OpenStack, so they did not solve OpenStack specific issues. So we had to write our own script that is called PSQL to MySQL. Again, it's available publicly in GitHub. It's a Python script basically. It runs in 3 steps, or basically 2 steps. First, you have this precheck call. You provide your MySQL database as a target option. Oh no, sorry. You provide only the source database, that is the Postgres one, and it does the checks for the cases that cannot be automatically solved, like the UTF problem, right? So it basically scans your database for the occurrences of those forbidden characters and tells you, hey, you have this character and in this place of the table, fix it manually. We just cannot drop it automatically. Well, we could drop it, but I don't think users would like us. So after you run the pre-check and it ends with no errors, you could do the migration. It basically takes all the tables of your original table, of your original database, and copies them to the new one. And that's it about database migration. As I said, there is a larger session about this. There was a larger session about this in last OpenStack Summit. So if you would like to know more about this SQL migration tool, you could find it in the archives of the Berlin Summit. So now back to the upgrade. I wanted, I kind of implied, but I'm not sure if I said it explicitly, that the upgrade provides a set of tools. There's a web-based tool that is basically the extension of the Crowbar web UI, and there's a command line tool. You basically have this Crowbar CTL upgrade command, and you provide set of steps that are that have to run in specific order, and each of the step does specific action related to the upgrade. So if you call the status command, it tells you obviously the status of the upgrade. The prechecks is the one for those original prechecks, and it tells you that upgrade is possible, upgrade is not possible because, or only normal upgrade is possible because, for example, you do not have HA setup configured, so non-disruptive upgrade cannot be possible, right? So this is, it's not just 3 steps. There are like 7 steps or so. Nodes is the last one. That's the last step that basically cares about upgrading all the cloud nodes. Oh yeah, so some more information. Everything is logged. There's specific log about that contains information about upgrading admin server. There's a similar log that contains all the information about each cloud node that is being upgraded, and there is this YAML file that actually tracks the information about current upgrade state. And I believe that's it. I originally wanted to show some real demo, but unfortunately I only have this Windows machine and I do not have I cannot connect to my development setup. So any questions? Okay, that's it then. Thank you.